Okay, so now we're going to be working on question 5, or analysis of trusses, section 6.1. So, um, the question is, for the following bridge, the bridge refers to this, to I, right here. I already have drawn the other two. The other two drawings I'm going to use for this just to try to save time, so that way I'm not taking up as much time. But for the following bridge, determine the force on member BF and whether it's in tension or compression. So I'm going to quickly just review what tension and compression is. Tension refers to when the arrows point in on the shape, while compression refers to when the arrows point away on the shape. So that being said, let's get started. So first thing we're going to do on this is we do our second drawing here where I have my II. Because what we're going to first do is we're going to figure out the forces, our reaction forces on it, which are external forces. So we first ignore the center part and focus purely on the outside. So I like to redraw it as I like to redraw it without any of the stuff in the center, just to help me get an idea of how I'm going to go about this. Now, I'm also going to mention right now that R sub C here should be two values. It should be C sub Y as well as C sub X. However, as you'll see, C sub X will not matter because it is the only X direction thing. So for instance, if I do sigma F of X comma I, I'm just going to use I so that way I'm showing what direction is. This equals 0. Now, if you look at this at sorry, I meant II on this one. If you look at this, you'll notice that there is nothing in the X direction. However, the C sub X would. So that tells me that C sub X equals 0, which is why we can ignore it and focus on C sub Y, and that's why R sub C is required to be vertical. So now what we're going to do is we're going to start solving for our R sub A and R sub C. So that brings me to F of Y, comma, I equals 0. What I'm going to first do is list our positive values. So our two positive values for this would be R sub A plus R sub C. Now, all of our other values that we have listed are going to be negative. So that's going to be minus 150, minus 100, minus 200, minus 200, minus 200 equals 0. So what we're going to do now is we're going to combine our like terms, or for instance, combine our constants as well. So if we do that, we get R sub A plus R sub C minus 850, because that's what happens when you get your sum of all of those values. It's 850, well, negative 850. And this all equals 0. So that tells me that R sub A plus R sub C equals 0. I'm sorry, not equals 0, equals 850, my bad, equals 850. So now what I'm going to do is I'm going to move on to using a moment equation. And I'm going to be using a moment equation just because I can use it to get rid of one of my variables. In order to get rid of one of my variables, I have to choose either point A or point C. Now I'm going to choose point C. There's no real reason why I have to choose point C. I just am going to choose point C. I could easily do it with point A because I'll still get the same answer. However, I could not do it with point B, D, E, or F, because if I do that, I won't be eliminating one of my variables. So therefore, sigma of moment of the graph II at point C, And now keep in mind, all that's going to matter in this is the y direction. So and the way that I'm going to do that is I multiply the force of the going in the y direction by the distance it is from point C on the horizontally. So that means and the way that this works too is if it's creating a force that causes a counterclockwise rotation, that means that it'll be positive, while if it causes a clockwise rotation, it's going to be negative. So that tells me that I'm going to do 200 times the distance it is, which we get from here, from I, times 2.5, plus 200 times 5, plus 200 times 7.5, plus 150 times 15 times 10. I was getting a little ahead of myself. That ends up equaling 150 there, but I haven't done that out. Minus 10 r sub a equals 0. So now I'm going to multiply everything out and combine my constants. So when I do this, I end up getting 4,500 minus r sub a equals, minus 10 r sub a, 10 r sub a equals 0. So now I'm going to move it, I'm going to move my 10 r sub a over to the other side, and then I'm going to reverse my equation, just that way it's easier to read. So 10 r sub a equals 4,500. That tells me that r sub a equals 450, because when I divide 4,500 by 10, I get 450. So now what I'm going to do is I'm going to use that and plug this in to my equation up here to get r sub c. So that tells me that 450 plus r sub c equals 850, which means when I subtract 450 to the other side, I end up getting r sub c equals 400. So now I can start moving on to actually doing another equation. So what I'm going to go actually here is you can do it from here. You can go two different directions with it. You can either go in you can either create sections and work on it there to try to solve for BF and get your answer for BF, or you can do it the way I'm going to do it, where I use points from this diagram here. I'm going to use points to try to solve for it because I find that way a little easier personally. So that being said, we're going to first start off with point A. Now we could also start off with point C. However, I'm going to start off with point A, and I'm going to use that to work my way to BF. BF I've already made green on this graph, just to try to make it a little easier to see where I'm going for it entirely. Now, I'm using the method of points when I do this. And when I do the method of points, I like to assume everything is in tension. While I'm aware that it is possible that many of these could be in compression, I like to assume all of it's in tension because it's just a standard that I can go for. I could also easily assume all are in compression. However, I learned tension first. So that's just the way I like to do it. So now we're going to be moving on to this, and therefore I'm just going to state right here that we are going to be using diagram 3 for the rest of it. Now I've already written in what our r sub a value is and our r sub c value is, which means that when I actually go to solve these, I'm going to want to start from either point A or point C. I'm going to choose point A. Because this way limits the amount of unknowns we have. For instance, if you look here at A, we only have 2 unknowns. If you look at D, we have 4 unknowns. If you look at F, we have 3 unknowns. And if you look at B, we have 5 unknowns. So therefore, it only makes sense really to choose R sub A or R sub C because we want to try to get rid of our unknowns to solve for BF. So what I'm going to first do is start from point A. Now I'm going to try to limit, as I said, as many unknowns as possible so I could solve for them as necessary, which means I'm going to start off by using F sub A, F from A in the Y direction. This should all equal 0. So I'm going to just draw point A over here so that way it's just a little easier to see. We got one force coming down of 150 newtons. We know this. We also have one force coming up of 450 newtons. We have one unknown force here, which is AD, and we have another unknown force here, which is AB. Now, if we look back at our first at diagram I, we can see that it's actually an equilateral triangle. So angle FAC is going to be 60 degrees, which that means right in here, that's 60 already. So what I'm going to do is I'm going to work my way to try to solve for BF. And in doing so, I'm going to focus mainly on this part of the triangle up here, mainly because I just find that a little easier to do. And I'm going to just erase that because it gets in the way of some values. So doing so, that brings me to this part here. So first things first, we have an upward force of 450 newtons, and we have a downward force of 150. Now, if you look, AB is horizontal, so it's not going to matter, which then brings me to AD, so I get plus AD times sine of 60, and this equals 0. So that tells me here that when I combine my like terms and constants and all that, I get 300 plus AD sine 60 equals 0. Which when I rewrite, I'm going to get AD sine 60 equals negative 300. Now I'm going to divide both sides by sine 60. And when I do that, I get AD equals 300, negative 346.41. Now, I was assuming that this was in tension, which I'm just going to label T. However, because this is negative, I now know that it's actually not in tension and it's actually in compression. So that means it's actually 346.41 in compression, which means if I go back to this diagram up here, the arrow should not actually be pointed that way, but instead pointed towards the corner. Now I can also go into my next point here, where my next point is going to be at point D. I could also try to solve for AB and do it and go that way and work my way all the way around. However, I'm going to try to avoid point B because it has 5 unknowns. So I'm going to be going around that wherever possible. So that brings me to here, where I'm going to use that because I'm going to ignore AB because AB is not going to have any effect on D. So that's why I'm ignoring AB, because I'm trying to avoid point B because it has so many different unknowns. So that brings me to point D. Now, there's a thing at point D that you might notice. At point D, we have, well, because it's in compression, because this is in compression, that's why I drew the arrow that way. So because that's in compression and there's another force that follows it exactly, just on the opposite side of it, those two forces actually have to be equal. So AD actually equals AD actually equals DF, which means that I can actually say that because AD is 346.41 in compression, so is DF. DF equals 346.41 in compression. Now, if I look back at this, I also can tell at point D, none of the other forces are going to go and affect point F. So that moves me on to point F, where now I only have 2 unknowns, while if I was to keep pushing through point D, I still have another 3 unknowns to solve. So I'm going to move on to point F now because I already discovered one of the forces going there. So that brings me to sigma F, and I'm going to use a little f when I'm showing this point, just so that way it's different than the big F. And I'm going to use in the direction of X because I'm trying to limit my unknowns as I go here. So I only know one unknown in F. And that would be, here, I'll draw it out. So at point F, there's 4 forces, but there's 4 forces. However, one we know to be 200. We know another one to be 346. And we don't know 2 of them. So I'm going to keep assuming that these 2 are in tension until I've proven otherwise. So I'm going to start off with solving this out in the X direction because that will limit my the number of unknowns I have working on it. Because if I was going in the Y direction, I have 2 unknowns. So I'm going to try to limit that and first solve for my other unknown. My other unknown would be FE. So going into this, I'll bring back to now finding these angles. So I know that this overall angle up here, the angle F, is going to be 60 degrees. So angle AFC equals 60 degrees. Now I also know that BF is vertical and divides that angle, which means it divides the angle into 2. So I can do 60 divided by 2, and that equals 30 degrees. So each of these angles here is 30. Which then allows me to start focusing on this. Now I have DF times, and now because we're working in the X direction, it's going to be sine 30 plus, because the arrow points positive for X, plus FE times sine 30 because the 2 angles are the same. And this should all equal 0. So when I actually go to solve this out, I end up getting, I'm going to put in my substitutions. You can get 346.41 plus FE, 346 times sine, I was going ahead of myself again, sine 30 plus FE times sine 30 equals 0. So that brings me to my next part. So I'm going to subtract my 346.41 to the other side, which then gives me FE sine 30 equals negative 346.41 sine 30. So what I'm going to do here is I'm going to divide my sine 30s, which gives me FE equals negative 346.41. Now, if you remember, this is in tension because I assumed all of them were in tension. So because it's negative, that actually tells me it's 346.41 in compression. So that actually tells me that this arrow here that I had should actually be pointed at up. Now this brings me to only one unknown left to solve for at point F, and that would be my point BF that I'm looking for. So now I go sigma F sub F time, comma Y equals 0. Sorry, I never wrote equals 0 up here. Now, I'm first going to, now because I know that these are in compression, FE and DF are in compression, that tells me that both of them are going to actually be a vertical force and therefore be positive in Y. So I'm going to write those first. You get 346.41 times, and I'm still going to use that same angle of 30 because I know it. However, this time it's going to be cosine because I'm using it in the Y direction. So cosine 30 plus, and now I also have to use FE because I've already established that DF and FE are the same values. So that tells me it's going to be 346.41 cosine 30. Now it's going to be minus 200 because I have a force of 200 going down on it, and minus BF because we are assuming BF is in compression. So, and this all equals 0. So doing that, my first move is going to be to try to separate BF away from everything else. So I'm going to move BF over, and then I'm going to reverse the whole thing, just that way it's a little easier to read. So BF equals 300, and I'm also going to do this because if you look here, these two values are the same. So it's the same thing as saying just one of these times 2. So I'm just going to do that as well, just to make it a little more condensed. 346.41 cosine 30. And this would be minus 200. Now, when I do this out, I actually end up getting BF equals 2 times 300 minus 200. So this is the same as writing 600 minus 200, which means BF equals 400 newtons. And now because this is positive and not negative, it means it's in tension, as we assumed all of them were in tension at the start. So therefore, our answer is BF equals 400 newtons in tension. Thank you.